Welcome to today's video lesson where we will look at alkene nomenclature, so that's hydrocarbon chains with one or more double bonds in their structure. So let's look at these examples starting with C2H4. Let's draw the Lewis dot diagram for this compound. Now, in order to get this compound to work, so that's C2, H4, so 1, 2, 3, 4. So as you can see, I had to use a double bond to get this formula to work, remembering that carbon needs to have 4 bonds in its structure, in any Lewis structure. So there's my Lewis dot diagram. And if I use my prefix chart and I see that there's 2 carbons, remember that I know that this compound will start with the term eth. Now, because it's an alkene, okay, because of the double bond, the ending will change from ane to ene. So if this was a singly bonded 2-carbon compound, I would call it ethane, but because of the double bond, I'm going to call it ethene. So let's try another one, C3H6. So we're going to draw the Lewis structure. C3H6 looks like this. Each carbon has a maximum of 4 bonds, so that will give you 6 hydrogens. So 1, 2, 3, 4, 5, 6. I'm not going to draw all the H's, but you get the idea. So if I go to my prefix chart, it's a 3-carbon parent chain, so it will start with prop. But because of the double bond and the fact that it's an alkene, my ending will be ene. So I've got ethene and propene. Those are doubly bonded parent chains. Now let's try a more difficult one, C4H8. So here's my Lewis structure, 4 carbons, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. So again, each carbon, remember, has to have 4 bonds, right? Okay, so if I go to my prefix chart, there's 4 carbons in my parent chain, so that's bute. And then because of the double bond, I know it's an alkene, so butene. However, because this is a longer parent chain, I have to apply some nomenclature rules. So I actually need to number my parent chain carbon atoms, and I'll number it this way. So I'm going to call this carbon 1, and then we're going to go across. So 1, 2, 3, 4. And what I need to do in my nomenclature is I have to indicate on what carbon number does that double bond fall on. And I can see that it falls, the double bond is between carbons 1 and 2, but we are going to give it the smallest number here, which is 1. So my nomenclature is going to look like this. Bute 1 ene. So bute-1-ene is what we call this compound. The 1 and the ene, this means that the double bond is on carbon 1, or it's between 1 and 2. Now, I didn't have to do that for ethene and propene because ethene, there's only one structure for it. So like the double bond, for example, it's always on carbon 1. Same thing with the propene. It's always going to be on carbon 1. Even if I put the double bond here, for example, I would just number it backwards and I would still call that carbon 1. So we only use this for longer carbon chains where we have to indicate what carbon number does that double bond fall on. By the way, this that I'm showing you, this is the updated nomenclature, updated new nomenclature. So it's the IUPAC nomenclature rule. There is an older version of this where you can also call this 1-butene, but I think it's good to learn the new way. So try to get used to that format, and we'll do that throughout the video. Okay, now let's go and look at cyclical structures. So we didn't cover this in episode 1, which was on alkanes, so we can kind of look at this now. So if I have a hexagon, just a regular hexagon, this is an alkane. So each of these vertices or lines, that represents a single bond, and there's a carbon at each vertex. So in my regular hexagon, this is a hexane. Okay, so that's a 6-carbon hex, and it's all singly bonded, so it's a hexane. But when it's in a cyclical format or a ring, we put the prefix cyclo in front. So this becomes cyclohexane. Now, if we look at the structure beside it, it's very similar, but you can see this extra little line here. That means there's a double bond between this carbon and this carbon, so this makes this an alkene. So this one was just the parent chain alkane, and then this one's an alkene. So in terms of our nomenclature, it's still a cyclohex, but rather than calling this cyclohexane, we're going to call it cyclohexene. Okay, now technically the double bond does occur between carbon 1 and 2 if we number it like that, but when it's in a circle, if you only have one double bond, that carbon is always going to be carbon 1, right? Because you're going to define the carbon numbers as you number them. So this is just called cyclohexene. The 1 is kind of implied. Okay, now let's look at the 2 alkenes underneath, because these are special organic structures. There is a special name for these structures. We can call either of these, this is called benzene, which you may have heard of before. Now, if you want to do the nomenclature version of benzene, it's a cyclo, hex, and then this is, let's say this is carbon 1, 2, 3, 4, 5, 6. And then in the other one, because this is a resonated structure, we can call this carbon 1, 2, 3, 4, 5, 6. So I'm numbering it to give the double bonds the smallest number possible. So it's a cyclohexa 1, 3, 5 triene. This is its like nomenclature name, but because this is resonated, we use this name to refer to this structure, and I'm sure you'll learn more about this in other organic classes. So it's just called benzene, but its organic name is cyclohexa 135 triene. Okay, so let's look at a sample compound and name one. So here are my nomenclature rules for complex alkene compounds. It's very similar to alkanes. So we're going to determine the parent chain, which is going to be my longest chain that includes the double bond. And then we're going to determine if we have substituent groups. We're going to number our carbons in the parent chain, giving my double bonds the smallest number possible. And then we're going to name the substituents in alphabetical order. Okay, so there's a lot of rules, but let's just apply them to this example. So I've got a compound, I've got a parent chain and a substituent group. If you're not sure what I mean by that, you can refer back to episode 1. So I'm going to have to number the parent chain, and I can do it in 2 ways. I can either number it like this, 1, 2, 3, 4, 5, 6. So that's the chain with my double bond in it, but I'm not going to do it that way because I have to give my double bonds the smallest numbers possible. So if I go from right to left, the double bond is between carbon 5 and 6, and that's a little too large. So we're going to actually number these from left to right. Okay, so let's make a correction. We're going to call this carbon 1, and we'll go across like this. So what I can see now is that my double bond falls on between carbons 1 and 2, giving them the smallest number possible. So my parent chain is the 1 through 6, and then this becomes a substituent group. Okay, so that's like a side group. And if you guys remember from lesson 1, CH3 is methyl. Okay, so this is methyl. And this methyl, we have to also tell what carbon number it's on. It happens to fall on carbon 3. So if we put this whole name together, this would be a 3-methyl hex 1 ene. Okay, so 3-methyl hex 1 ene. We've got a methyl on carbon 3 and a double bond on carbon 1. That's how we do the nomenclature for this compound. If you have any questions, let me know in the comment section, and it would be great if you could like and subscribe. Thank you so much for watching.